this question today. I'm going to do it first in JavaScript. I'm learning Golang, so I'll try to do it later on up in Golang. Okay, reschedule meetings for maximum free time. Version 2. We are given integer event time, denoting the duration of an event. You're also given two integer arrays, start time and end time, each of length n. These represent the start and end time of non-overlapping meetings that occur during the event time between from 0 to that time, where I meeting occurs during the time given here. So that will be the boundary of each meeting. You can reschedule at most one meeting by moving its start time while maintaining the same duration. So we want to reschedule at most one meeting, and we can move it. We can move it start to maintain the same duration. We need to keep it non-overlapping, and we need to maximize the longest continuous period of free time during the event. We want to return maximum amount of free time possible after rearranging the meetings. Note that the meeting cannot be rescheduled to a time outside of the event, and they should remain non-overlapping. In this version, it is valid to change relative ordering of the meeting after rescheduling. So yeah, we can essentially move can move the meeting. We could move, for example, that meeting, here, and in that way we would get, a larger gap, and that gap would be then maximum maximum free time within the event time. Yeah, so we could also move it, to the right, or we could move it, even here. But event time is up to 5, so we cannot. But if that was up to 6, then we could move it, like on the other side, to the right. Could move it like to the right of one of the next blocks, to the right or to the left. So that's sort of something which we want to simulate. We want to either we want to move it either like to some gap on the right. Yeah? But we can move it there only if there is enough space. Yeah? So there needs to be like space, at least as big as the space of that block. Or we could move it, to the left in the same way, or we can just move it to the like to the right of or left, but without jumping over any of those blocks. Yeah, if we simulate that, yeah, we should be able to sort of like select the best answer. So essentially we're doing that in greedy way. Yeah, those are, I think, already sorted. So those are already, that means they are already sorted. Okay, so the way we can do it is essentially sort of our first step would be to calculate all those available gaps, like gaps, and then once we have gaps, we can we need to have a way to know if we are able to move the current block to the right or left. Um, and to do sort of the way to do it would be by having some sort of data structure which keeps track if there's something, if there's a bigger gap on the right. And for that we can use essentially suffix. So we can run through our gaps, and we can keep like track of like if there's something bigger on the left from the current position. We can do it. We need to do it also from the left, but we can kind of like combine it once we iterate over our events. Yeah, we can kind of like we iterating over that from left to right, so we can kind of keep track of the prefix which is gonna store like the biggest gap on the left. And once we iterate over our events, yeah, we'll be checking if like what will happen if we move it to the left or to the right. If we move it to the left or right, yeah, we essentially gaining that entire space. Yeah? So if I move that somewhere here, I'm gaining I'm gaining my left gap or right gap and that duration. So that becomes my possible answer, and I need to find the biggest. Yeah, if there's a possibility that we cannot even move it like outside. So we need to also check like what happens if we just move it slightly to the left without jumping over it, because that could be also a possible answer, which is actually possible, which is actually the answer for example one. Okay, so then let's say really cool. Best answer. Okay, so now the first step would be to calculate our gaps. And we're gonna store it in array. And we're gonna have actually we're gonna have n+1 gaps, yeah, because we're gonna have some gap before and at the end and in the middle. So we have, in this case, we have two events. So for two events, yeah, we have like one gap in between them, but we need to also like remember about gaps at the start and at the end. And that will be the amount of those gaps will be n+1. That's and n will be our start time, length of, or amount of our events. Okay. Now we can calculate straight away our first gap, which will be or the way we can do it is we can say our let's have variable storing our previous and now we're gonna iterate over our events. We could use our n variable and sort of the start will be start time at I, and our end of our current event will be end time at I. And now we can say that the gap will be the gap at I will be equal to current start, yeah, the current start minus previous end, ending of the previous event, and then we need to keep updating our previous and current. Okay, so in that way, we're gonna have like the first n gaps, but there will be also like one gap at the end, possibly one gap at the end. So let's remember about that gap, and that will be event time, so the entire time of the event minus again previous n. Okay, so in this way we have gaps. Now let's calculate our suffix. Yeah, so our data structure, which tells us if there's something bigger on the right. Yeah? So let's say we'll have suffix. That'll be again a new array at. That'll be again gonna have n plus one, and gonna fill it with 0. Okay, and then we iterate through our gaps. Yeah, so from the end. Yeah, we want to see if there's something on the right. What's sort of like the biggest thing on the right? And so we start at n minus 1. I bigger equal to 0 and I plus plus. And now our suffix at I will be equal to max between suffix, like the previous suffix. We iterate from the right, is we like the next suffix. Or the gap, yeah, the like that gap from before. Yeah? So like later on when we will be using that, yeah, we'll be at index I, and at that index we want to see if there is something on the right from that index, which is bigger. Or we want to like see what's the biggest element on the right from our current index. So that's why again, like here we're checking for gaps from the like the previous gap. Okay, and now we have suffix. We could do the same for the prefix, but prefix we can actually calculate like on the go. So we can say that I'll just call it left prefix or left left max, and that'll be at 0. And then we can just go over our events again. So it will be sort of done in that way. So we have start with end. And now we want to see our so we want to see if we can move it to somewhere on the left. Yeah, if we can like move it, move, let's say, that block to the left. Not only move it to the left, but jump to some jump over some blocks on the left and put it into some space there. So now to do it, we can say that so my gap on the left will be equal to equal to gaps at I, or yeah, I'm just thinking because now if our left, so we can also calculate like duration of the meeting, which is end minus start, and now if there was something, if my left max was big enough to fit that duration, we could put it there. Or if I have something on the right, if I have enough space on the right, so I can say that if suffix at I is bigger or equal duration, then I can like fit it to the right. Yeah? And now if I can fit it to the right, it means that my best uh, space, best available space. Yeah, so now if I put that block, yeah, somewhere like I will put it like I will like jump it through some blocks on either left or right. Yeah? I can do it if I have enough space there. Then it means that that entire space, gap on the right, gap on the left, and that duration, that's my new gap, yeah? Which could be possible answer. So that's why I'm gonna say that um, my best available space will be either my already best available space or duration plus gap and I, yeah, which is like for I0 will be that first gap plus gap on the right, yeah, which will be gaps at I plus 1. Okay, so that's one option, but there could be also possibly we could just move it to the left or right, yeah? And just moving that to one side without jumping over other blocks. That could already be good enough answer. That could be already a space, potentially the best space. Yeah, yeah. Especially if there's like nothing. If we cannot fit essentially that kind of block anywhere, then that could be best answer. So that's why we're gonna say that best available space could be also a max between my current best available space or gap on the left plus gap on the right. And then at the end I will be just returning best available space. Okay, so now let's see how that works. Yeah, something didn't work well. Looks like we have some sort of infinite loop. Yeah, here we want to go to from right to left. Okay, we get 3. Looks like some sort of one of error maybe. Okay, we have our suffixes. That looks correct. Left, yeah, we need to keep track of our left max. Yeah, we could have like prefix, but we can calculate that on the go. Yeah, on the go we can say that my left max will be either my current left max, or it will be essentially gap to the gap gaps to the left. Yeah? Gaps at I. Okay. Okay, let's see. Yeah, we have a duration. We have our gaps. Um, mm, Yeah, I'm thinking if I calculate our suffix correctly. So yeah, actually, yeah. So in this case, like suffix at I, so suffix at n minus one would be equal uh, to the gap which we have on the right. Yeah, we actually need to check suffix at I plus one, because when we add I, so let's say if we are at the last event, if we are at the uh, last event, um, so let's say if we are at that event, we want to check if there are any like spaces available on the right, but not immediate spaces, but spaces like if we jumped over it, um, like the next space. So that's why that would be so um, that would be like n, yeah. So that would be n, um, and here we go up until n. So we need to check I plus one, which is gonna give us n. Okay. Looks that it worked. Yeah, thank you very much. I will also attempt to do it. I'm learning Golang, so I will attempt it now also in Golang. But that will be the next video. Thank you very much.